Welcome to the Department of A-Level Computer Science Open Day 2020. There are 3 teachers within the department: Miss Bullen, our head of department, Mr. Austin Lacey, who teaches A-Level Computer Science and BTEC ICT, and myself, Mr. Gosling, who teaches A-Level Computer Science and BTEC Computer Science. The Computer Science Department can be found on the top floor of the Ellis and Kennedy building, to the right in the main stairwell, in rooms E414 to E423. In order to qualify to come on the A-Level course, you must first meet the college requirements for A-Levels. That is 6 grade 4s or above, with at least 2 grade 6s, with at least one of those 6s in Maths, English or Science. As well as that, we do, I'm afraid, insist on you achieving at least a grade 6 in GCSE Mathematics, as the course requires a lot of mathematical content. You do not have to have done GCSE Computer Science, but if you have, you should have done that well. Obviously, if you can't do well in GCSE, you shouldn't be doing it at A-Level. But if you have achieved it at GCSE, then it is an advantage to you. You'll find the first term less challenging than some of the others, as you're already familiar with some of the content. However, if you haven't sat GCSE Computer Science already, don't worry. We start from the beginning, you'll be fine. The exam board we've chosen to use is the OCR board. We find it is not as challenging as some of the other boards, and also not as easy as some of the other ones. It's a nice middle ground which suits most of our students. Now, the course itself is made up of 3 components. The first is computer systems, which makes up 40% of the overall grade, and that is based on all the hardware and software requirements, as well as other theory aspects. The second component is another exam, 2.5 hours long, making up another 40% of your qualification, based on algorithms and programming. So you have to learn to program and debug programs using pseudocode, as well as learning all the standard algorithms like sort, search, tree traversal. And finally, the third component is your programming project, which makes up 20% of the grade. So what do we actually do on the course? Well, one of the things we do is learn how to solve problems, how to decompose the problem down into smaller and smaller parts until eventually the small parts are all solvable, therefore we can solve the whole. We also learn about computer systems hardware, the CPU, the fetch, decode, execute cycle, and the operation within the CPU and the RAM. We look at operating systems, their role within the computer environment. We learn how computers work with binary and with hexadecimal. We move on to then looking at networking and data transmission between computers along different networking systems. We look at programming, and this is one of the major skills to learn, is we learn to program in a language called visualbasic.net. We also do a bit of programming in websites by making websites using HTML, CSS and JavaScript. We also look at agile development methodologies, which is one of the latest approaches to designing and building systems. We also learn to think computationally, algebraically, logically, in order to solve solutions in a logical approach. And one of the other big subjects we look at is algorithms, the step-by-step approach to solving simple problems like sort, search, and more advanced ones like tree traversal. So what does this coursework entail? Well, the coursework project is an extended piece of work, making up 20% of the grades, but you spend a lot more time than that preparing for it, learning to get your skills up and ready, and you only started later in the first year once you've developed your skills to a suitable standard. We don't set the projects, the students suggest a possible project, and then us as teachers have to agree that it is suitable and that it meets all the requirements. The students will then go on to produce a detailed write-up of the following stages. They start with the analysis, where they have to break the problem down and to work out what it entails and to set all the requirements for that project. They then have to go on and design it. They design all the layouts, all the screens, all the algorithms they're going to use, and then finally they start implementation, where they actually start building that project, recording as they go along and coding it and testing it and reviewing it regularly. They then go on to final testing to test it for functionality and does it meet all the requirements. And finally, they have to then sit down and evaluate the whole system and write that up in detail. The whole thing can easily fit 120 pages or more. So what can this project be about? Well, it could be about simulation, for instance, ballistic trajectories, crowd control, various things like that. It could be a game, They go and produce the game, like a variation on Pac-Man, old games like that. It could be some of booking system, or a library system, or it could be an adaptive quiz, not just an ordinary quiz, but a quiz that adapts according to how well the person's doing, and many, many more possibilities. It can be practically anything so long as it's achievable by that student in the time they're allowed, the resources and systems are available for them to do it, and it has the potential to be difficult enough to be classed as an A-level project. And all that is why we as teachers must agree it. Now in computer science we don't teach in quite the normal way. Instead of doing the old-fashioned approach of the teacher standing up and teaching for the lesson, the kids doing some work and then doing some more work for homework, we have flipped those lessons. Instead, what the kids do is they go home, they watch videos, they make their own notes, so they're learning at home. And then in college, we clarify any issues they may have, do more consolidation techniques and exercises and so on, so they're learning it in college where we can help and push them on. And then there may be a bit more to follow that up afterwards, but normally they're then ready to move on for the next lesson and to start it all again. Now the work that they produce is all submitted online, and then together with regular testing, this has proven to be a much more productive way of learning. When it comes to the resources we use, most of the resources we have created, they're bespoke. That includes the booklets, the SLR files, the presentations and videos that the students watch in the Flip Learning. They're all available online and the booklets are printed out so they all have paper copies. We do sometimes use textbooks, however infrequently, and there is no requirement for you to buy those. So what sort of career can you expect with an A-level in computer science? Well, you can of course move on to do computer science, to be a programmer, software engineering. You can end up going into engineering, aeronautical engineering, mechanical engineering is also quite popular. You could go into web design, cloud computing. Cyber security is a big issue at the moment. They can't find enough people to fill all the vacancies. You could go into a more business and information systems approach where you're actually building systems for businesses. You could really stretch it with artificial intelligence. You can do robotics, software engineering, similar to computer science. You could move into games design, although there aren't as many places in that as people think, and it's not the same job as people think it is, or even database development. Almost every system in the world has to have a database behind it, even Google. Now a great many of our students end up going to university all around the country, from universities of all different types. Some have even ended up going to Oxford and Cambridge. The sort of degrees they can move into are degrees in computer science, in software engineering, in aeronautical engineering and other types of engineering, and degrees in cybersecurity, etc. It's virtually endless. Should make a note at this point, however, that a lot of these universities for some of these degrees do require an A-level in maths and a high grade at that. So, for instance, Manchester University want an A-star in mathematics to do a degree in computer science. It's something you must bear in mind. Another thing to consider would be degree apprenticeships for the very best students. If they can get spotted by a company, they'll actually pay their way through university for them. So they leave university with a degree and a job and no loan to pay off. Now for a bit of fun, whether you take computer science as a course or not, you could join the coding club. This tends to run sometimes on an afternoon, sometimes after college. You go in, you can get some help with your work if needs be, but the real aim is to try and sit there and actually learn to make and program some robots. You can get to use the Raspberry Pi and code things like this, the code bug or the microbit. You can try other languages and the VB we were doing in the main lessons. You get to discuss things with other teachers and other students as well, not always based on the subject. Generally have fun. Some of our students have even managed to use this to take steps on to do hackathon events, and they've won those competitions. Some of them have even been noticed by companies to get onto those degree apprenticeships I mentioned earlier. Well, we've reached the end. We hope you've enjoyed the presentation, and we do look forward to seeing you here at enrolment next autumn. Just remember, work hard, good luck with those exams, and thank you for visiting.